Now we are moving on to the displacement time graph, one of the most important ones. Displacement time graph, right? Displacement time graph. So you know the displacement is the shortest distance between two places. The shortest distance between two places. So when it comes to the displacement time graph, in this we have two axes, same like normal graphs. We have y-axis and we have x-axis. To the y-axis, what we have is the displacement measured in meters, and in the x-axis we have the time, most of the time measured in seconds, right? In the y-axis, displacement measured from meters. In the y-axis, x-axis, time measured from second, right? So in this displacement time graph, there are three ways that you can get. So now we have this displacement time graph, right? So these are the three instances that you can get in a displacement time graph, right? So in this thing, what explains is displacement is increasing, right? Displacement is increasing. Going from A to B, displacement is increasing, going from A to B, right? Then this thing, right? This thing says staying stationary, which means the displacement haven't increased or decreased. The displacement here, displacement is measured from meters, no, is 2000 meters, right? 2000 meters. So 2000 meters වෙනකන් displacement එක වැඩි වෙලා, the displacement has increased until 2000 meters and now staying at the same 2000 meters for some time. Time is spending, right? Time is spending, but the person is at the same position. So this is staying stationary. Now what's happening here? Right? Metheran is 0, this is 0. With the time, the displacement is reducing, which means coming back. Let's assume this is 100 seconds and this is 200 seconds and this is 300. 100, 200 and 300. So how can you explain this one? Let's assume this is Nimal going to a shop. Nimal started from his house. He started from his house and traveled 2000 meters within 100 seconds, which is impossible, right? Yeah, that's fine. So which is impossible. So he traveled 2000 meters within 100 seconds and he stayed at the shop B for another 100 seconds and came back to the home within another 100 seconds. Understood? That's how you can explain this motion. That's how you can explain this motion. These are the only three instances that you can have, right, in your displacement time graph. So from this displacement time graph, you can only do one calculation, but you can just tell 2 or 3 data from here. Looking at this one, you can say what is the displacement, right? The displacement with after 100 seconds, how much? 2000 meters. After 100 seconds, the displacement is 2000 meters. Final displacement is what? The final displacement is 0. After 100 seconds, the displacement is 2000 meters. The final displacement is 0. Right? So another thing, you can do a simple calculation from this velocity time graph. You can do a simple calculation from this velocity time graph, right? So the calculation that you can do is from the gradient you can find the velocity. In a displacement time graph, the most important thing is from the gradient you get the velocity, right? From the gradient you get the velocity. In mathematics, you learn how to find a gradient in a graph, don't you? Right? In mathematics, you learn how to find the gradient. What is the gradient of a graph? Gradient equals the difference between y coordinates, any two, you can take any coordinates, y, the difference between y values divided by the difference between x values, x1, x2, right? So this is going to be the gradient. Gradient එක නේ අපි ගන්නෙ. So from the gradient you get the velocity. Keep it in mind. Gradient equals to the velocity. So gradient means the difference between the y values of a coordinate divided by, of two coordinates divided by the difference between x values of two coordinates. Let's assume, or let's take these two coordinates. This is 100 0, 100 to 2000. X value is 100, 2000. This coordinate here 0 0, right? 100, 2000 and 0 0. I'll take this one as x1 y1 and I'll take this one as x2 y2, right? x1 y1 and x2 y2. This is x1 y1, this is x2 y2, right? So if you consider here, this is x1 y1 and this is x2 y2. So the gradient was equals to y1 minus y2 divided by x1 minus x2. y1 minus y2 divided by x1 minus x2. Understood? So look at this one. The gradient equals velocity. Keep it in mind. So y1 minus y2. What is y1? 2000. Minus y2. What is y2? 0. Right? What is the unit? That is meters, no? In the above it's meters. Divided by x1 minus x2. What is x1? If this is y1, this is x1. 100 minus again 0. Right? 100 minus 0 seconds. 2000 minus 0 divided by 100 minus 0. Right? So the answer is going to be 2000 divided by 100 ms minus 1. 2000 divided by 100 ms minus 1, because s comes to the top, right? So this becomes ms minus 1. So the final answer is going to be 20 ms minus 1, right? So the velocity of this person is what? 20 meters per second. The person has traveled in a velocity of 20 meters per second, right? I hope you understand. So the velocity is 20 meters per second. Look, right? If I consider this one from here to here, of course this is 0. I can prove to you that velocity equals gradient. No, I'll take this one. This is 200, 2000. 200, 2000. I'll take this one as I'll take x3 y3, the gradient in this one, no, the velocity. So look at this one, the velocity equals this minus this, 2000 minus 2000, 0 ni. So 0 divided by anything, 0. So of course this is 0. The velocity in here is 0. This is 300, no, right? 300. Look at this one. So the coordinate that we have here is 300, 0. The x value is 300, y value is 0. So the coordinate here 300, 0. Right? I'll take this one as x4, y4. Velocity is going to be the gradient. No? The velocity is going to be the gradient, right? You know that. Velocity is going to be the gradient. So velocity in this one is going to be the gradient of this one. y4 minus y3, 0 minus 2000 divided by 300 minus 200, right? So this is meters divided by seconds, no? Displacement, meters divided by second. So negative 2000 divided by 100, Negative 2000 divided by 100 ms minus 1. 0 to 0, 0 to 0 cancel out. This is negative 20 ms minus 1. In this one it was positive 20. Why this is negative 20 now? So velocity is a vector, as I said to you. So this is coming back. Since this is coming back, so this is negative. This is what's happening. Understood? So this is everything what you get in a displacement time graph.